So you are at Bump Up Your Cloud Infrastructure with Azure Bicep. That was a terrible Arnold impression. I'm so sorry. My name is Dustin from Centair. We're hiring, as Roy said. In addition to a great development culture, you can also have really lively discussions about things like whether or not you should cut donuts in half, interesting books, that sort of thing. It's a super fun place to work. And one of the cool things is that you just have a lot of people that are very passionate about development and doing good things for clients and just kind of life in general. Like whatever you're interested in, there's probably somebody else that works at Centair that's interested in that thing, all the way from like Lego to like hiking to whatever. Information wise, there's been LinkedIn, website, that sort of thing. If you want to look at the code that we're going to talk about today, including the stuff that I screenshotted, almost all of it's in the GitHub repo there. So, and if you need me to send that to you again, that's totally cool. So, the path to gains, knowledge gains specifically. First thing we're going to talk about is infrastructure as code. And the reason we're going to talk about that is so we can provide some context for our discussion, because Bicep is just another infrastructure as code technology, and we got to talk about where things come from, give you that context. Then we're going to talk about the Bicep language and how to use Bicep and different pro tips so that you can properly use Bicep. And a lot of those come from my experiences building an application, recent application using Bicep templates instead of ARM. So we built up an API application. We used Bicep. We built up, App Insights. Another person on the team built up a lot of the networking and stuff. And we really, we made it a point to use Bicep and use all the modern stuff just so we, get some good experience using it. And so a lot of these pro tips come from that experience and just trying to figure stuff out with a new technology. And then we'll cap it off with a demo. So we have an application environment that we are creating. It's going to include an app service plan, an application. It's going to include your monitoring and a database. So we'll show you how to do all that after the Bicep discussion. Sound good? All right, let's go. So infrastructure as code. Basically, infrastructure as code is it's kind of table stakes for DevOps. Like you really want to represent any of your infrastructure as some kind of script. So, but why? There are a couple of reasons. The first reason is speed. In the old universe, in order to get some sort of new infrastructure, like a new environment set up, you would go and you'd write a ticket and you'd spend a bunch of time gathering requirements. And then your infrastructure people would have some sort of project inception and a pizza party, it would take them 6 weeks, and they would build your environment and they'd send it back. And then you'd be like, well, this isn't what I wanted. And then you'd be like, well, did you include this requirement? And then you just go back and forth, and it's a real pain. But if everything is represented as code, in order to get your environment, all you have to do is run your script. Yeah, I mean, you got to write your script, but even if you have to write your script, run it, and it's wrong, guess what? It's code. You just edit it, resubmit it, and run it again. Another reason is consistency. So a lot of times, if you have somebody manually configuring environments, those environments may not get configured the same way over time. Those environments might become out of sync over the course of a project as your configuration drifts. So that's kind of a problem if everything is written as code and you need a new environment. Let's say you need a QA environment and you have your dev environment. Guess what? You're going to run your script that you already have, and it's going to give you an environment that looks just like your dev environment, except maybe a little bit of different configuration, maybe a higher service tier, different names, whatever. But it's going to look the same, and it's going to run the same, and it's going to be nice, as opposed to having somebody spend a couple weeks clicking buttons, and then you get something that may not necessarily be the same. Repeatability. Similar to consistency, you can get an environment, you can get consistently, you can get the same thing over and over again. So let's say you want to build a load test environment. In the old universe, you'd probably just end up blasting your QA environment or blasting your production environment with a bunch of load to see if things work. But the nice thing about using infrastructure as code and the cloud specifically is that you can take your scripts that you run to create your production environment, you run those bad boys, you have an identical environment, you have a repeatable environment, you can run your load tests, blow the thing up, who cares? Nobody's using it except you. And then at the end of the day, when you're done, you can just blow the thing up and you don't have to incur any more fees. So overall, infrastructure as code is table stakes for DevOps. It's extremely important that anything you're building in a modern application is represented in some sort of infrastructure as code technology. So let's talk about some infrastructure as code technologies. They come in two flavors. The first flavor is the procedural flavor. So this is the flavor, this is basically where you're going to write a script, and that script is going to tell the computer what to do in discrete steps. So provision a resource group, provision a VM, provision this, make this, 1, 2, 3, 4, down the list. And there are a couple different options you can use. So one option is Chef. It's pretty popular. Chef is a scripting type of language where you can create, they're called recipes, and you run them with a tool called a knife. It's just kind of festive. I don't know. I'm not a big Chef user, but a lot of people use it for on-prem deployments. A tool that I have used quite a bit is the Azure CLI. So that's another example of a procedural tool. So you can write an Azure CLI script to build up an application environment in PowerShell or Bash. And that works fairly well. Additionally, all the Azure APIs that all hit the same kind of REST API in the back end are also examples of procedural infrastructure as code. So, if you're using the C# API or the Python API or the Java API or whatever Azure API, it's all the same kind of deal. Is you're procedurally telling, the infrastructure what to do. And while this is valid and it works and it does what it's supposed to do most of the time, it's not, in my opinion, the most ideal way to write infrastructure as code. Personally, for my efforts, I want a declarative infrastructure as code experience. And so what that means is that instead of telling the computer what to do, you tell the computer what you want. Instead of saying, make me one of these, and then go make me one of these, and then set up this networking. Instead, I want to say, I want an application environment. It has these three things, and go figure out how to make them. Here you go. Here's your blueprint. Go build me a house. And there's a couple of different technologies that are more of the declarative style. The first is, if you've ever worked with Kubernetes, you can use a Kubernetes manifest. This is a YAML-based technology where you define your deployments and pods and services and other Kubernetes resources. And then you submit that you apply that to the Kubernetes instance, and it records that in the database. And then Kubernetes goes and figures out how to provision all that stuff, where to put where to put your VM or your Docker image, where to run it, how many resources to give it, all that kind of stuff. And you don't have to do any of that. You just have to tell it what you want, and it'll go figure it out for you. And then if it blows up, it'll respin it up. So it's a really handy way to, it's really convenient. And, you can actually use Kubernetes, in a more procedural way, but don't. It's much easier to apply manifest files. Terraform is another example of a declarative style. Again, another kind of YAML-based technology. Terraform is nice because it's cross-platform. So you can use Terraform, and you can use it to spin up your on-prem infrastructure, your Azure infrastructure, and other cloud is supported by Terraform. So it's convenient for that. One downside of Terraform is that you have to keep track of a state file that tracks where your infrastructure state is, so that when you apply your manifest again, it doesn't recreate everything. But it's no technology is perfect. One technology that does not have that limitation, though, are ARM templates. So this is the next declarative technology I want to dig into a little bit. And the reason is because Bicep templates are based on ARM templates. Everything that applies to ARM applies to Bicep. So let's dig into that a little bit. So ARM templates stand for Azure Resource Manager. And basically, it's a templating language that's JSON based. So you come in here and you define your different resources, parameters, etc. And then you can submit that to Azure as a deployment, and then it will spin up resources according to the definitions in your ARM template. So generally, if you have an ARM template, you have two different files. You have a template file and a parameters file, and each template file contains a certain number of sections. So you have at the top, you have like your schema content, and then you have your parameters section, which lists all the different parameters for your templates. You can define functions. They have a variables section, so you can define the different variables in your template. And then you have your resources, which is where you define your actual Azure resources. Meanwhile, over in the parameters file, you just define the parameters that you're going to use for your particular template. To deploy your ARM template, you're going to write a PowerShell script that looks a lot like this. Step one, you create like your own deployment number format, which is, you don't have to do that, but it just makes it easier. Step two, you're going to do an AZ group create, and you're going to make a resource group. You can do this in Azure PowerShell too. I mean, this is the CLI, but whatever. It's it's all just script. And then the next thing you're going to do is you're going to create a deployment group, and then you're going to submit that template and the parameters file into your deployment group. The template or the parameters file is optional. You can define the parameters in this command, but I don't know. I just find it easier to just define a parameter file. So ARM is cool, but there's a few problems. It's not all puppy dogs and rainbows. So the first problem with ARM templates is that they're Azure only. So you can't use your ARM template to build up your on-prem infrastructure. So that's one advantage that Terraform has over ARM. Two, they're kind of verbose. So if we roll back here, this is a kind of a verbose format. There's a lot going on here. There's a lot of, JSON in general, like it's better than XML, but it's still kind of a lot of typing and a lot of, cruft that's not necessarily valuable. So it's just kind of, it's kind of verbose, and it's really hard to get started. It's really hard to get started to write ARM templates because, the syntax is kind of opaque. The documentation is not fantastic. Like it'll give you like what fields exist, but other than that, like how those fields kind of mesh together just isn't terribly obvious. And you just kind of have to learn through experience and suffering in order to figure out how to use ARM. So it's not exactly a technology that has a really easy on-ramp. But in light of those things, Microsoft created a technology that has a lot of the advantages of ARM, but mediates some of these disadvantages. So it's less verbose, it's easier to get started, and that's where Bicep comes in. This is how you feel when you use Bicep templates. You feel real strong, like this guy here. Makes you feel good to be effective as a developer, build your infrastructure using Bicep. So, Azure Bicep. Let's start this off with a few miscellaneous Bicep facts. One, Bicep is a domain-specific language for Azure. It's very similar to ARM. It supports 100% of the Azure APIs from day one. This is another advantage over things like Terraform, because there's going to be at least a little bit of a delay. Though Terraform support for Azure is very good as far as I know. Bicep templates compile down into ARM templates. So basically, you can think of Bicep as kind of like TypeScript for ARM. They are much easier to read, and Bicep is built by Microsoft. So it is a technology that is built by Microsoft to make it easier to basically use Azure. Getting started with Bicep is pretty easy. So the first thing you're going to do is get yourself the Azure CLI, and you can also do this with Azure PowerShell. I don't use Azure PowerShell very much or at all, really. I'm more of a CLI kind of guy. So this is going to be the CLI path. You can do this with PowerShell too if you want. Go ahead and get yourself the Visual Code Bicep extension. Optional, but it's always good to have the right extensions in Visual Studio Code. And then give yourself a little AZ Bicep install. And what that's going to do is it's going to install the Bicep module into your Azure CLI So you can do AC Bicep commands. And then once you're there, you can do like an AC Bicep help, and then you can kind of figure out the commands and kind of traverse through the documentation. But I'm going to walk you through a few basics of the Bicep language just to kind of get you a little bit of familiarity, and then we can move on to pro tips and then our demo. So this is a basic template. This creates a storage account. And you can already see this is a lot easier to read than an ARM template. So up at the top, you have one parameter, that's storage name. It's got some attributes on there to determine a min and max length. If you look, you have your name, and it references that variable, location, SKU, kind, that sort of thing. And so this is just basically defining that storage account resource. Your API and type is going to be that Microsoft.storage/storage accounts, and then the @ will give you the actual API that you're deploying. So all that kind of happens in one line. And then that example storage next to resource, that's just the name of your resource. So if you wanted to reference it later and you wanted to like get the idea of it or the idea of it for another resource, you can reference it using that tag. To deploy that Bicep templates, you're going to write a PowerShell script that looks pretty much just like the PowerShell script you wrote to deploy the ARM template up above. So again, you just create your resource group, and then you do your AZ deployment group create to apply your Bicep template. And one of the nice things about Bicep is because it's built into Azure, and because it's built into, it's a Microsoft technology, you can actually just submit your Bicep template directly. You don't have to like compile it or mess with it or have any kind of a tool chain to go with it. You just send that Bicep up to the cloud, and it works like a champ. So it's pretty much interchangeable with your ARM files, which I like personally. Parameters. So parameters come in a few different flavors. Basically, you're going to have your param, then your name of the parameter, and then you can add a type to it. So you can have default values on your parameters if you want. You can also not have default values. You can use attributes to define things like what's allowed and what's not allowed. And then down at the bottom, you can set your default values with the string interpolation. So the $ curly braces there is just a basic kind of string interpolation you can use. So in ARM land, you have to use a function called concat to do this, but in Bicep world, we don't have to make you don't have to work that hard. Similar to parameters, you can also have variables. Those are denoted with the var keyword. So instead of having a variable section like in your ARM template, you can just define them where you want, and then it will compile them accordingly. Dependencies. So when you're building infrastructure, a lot of times you're going to include a bunch of different resources, and some of those resources are going to rely on other versions or other resources in the same group. And the thing about ARM templates and Bicep templates and all that is a lot of times this stuff happens in parallel. So you'll run into situations where you'll be referencing something downstream, and then it won't get built in time for your downstream resource. So if you have something like, for example, in this resource here, this is an Azure website, and that Azure website requires an app service plan. And so what we want to do here is we want to mark out that it depends on our app service and our app insights, so that we can wait until those things are done before referencing them or before trying to build this. So it'll run in the correct direction. So it's just something important there, or else you run into problems, and the problems aren't always consistent. Oh, somebody have a question?
Yeah, just a quick note, I guess, on that. Since you've got that app service ID for the farm ID, that should create an implicit depends on for you, so you shouldn't have to mark it out on your own. If you use a resource from another resource as part of it, it automatically, as it is, depends on.
I don't know. I ended up getting burned by this. Like, it threw some sort of wobbly on me. So, I mean, maybe it should. All I know is that I got burned, and I added in the depends on to
when in doubt, explicitly add it. You're right.
Yeah, so maybe it does, and maybe it's different, or maybe it just didn't work that time. I don't know.
Fair
I get
enough.
paranoid about this sort of thing sometimes, and
I gotcha. Nope.
but that's a good call out. All right. Another thing you can do is you can use functions, and you can use all the same functions you use in your templates, in your ARM templates. You can use those in Bicep as well. So in this case, this is a demonstration of the unique string function, which creates a hash of an input, which is a handy way to create things that, like unique passwords and things, especially if you don't ever want to see them again. You can like unique string a new GUID, and then you can get a nice string of characters that's very, very unguessable. Especially if you have the best password ever to that, like battery horse staple correct. And then, of course, you're super secure. Other useful functions that I find handy to lower, resource ID is a big one. Resource ID calculates the ID of a resource based on things like the name of a resource, the type of a resource. That's really handy if you don't have, if you're like trying to reference something that's outside of your template. So like, let's say you're building something and you want to reference like a VNet or some piece of networking, or just something that's shared across your applications. So it's not in your template. You can use resource ID to actually get the ID of that resource and calculate it out, as opposed to having to like drop in the resource directly. So that's a real handy one. And of course, things like contains. And, there's a bunch of different functions, for string manipulation, for equality, to traverse different Azure things. So you just look them up in the documentation, but just know that there's a lot of handy functions that are available to you. Another really nice feature of the Azure Bicep is modules. So modules are a way to break down your template into individual files so that it's easier for you to read. This is an example of a module, or at least the top half of that module, and we'll show you the rest of it in a minute. But basically, you just define a normal Azure Bicep template with your resources, parameters and resources, and then at the bottom you can define a few outputs to go with it. And you can consume that module using the module keyword, and then you can reference that file directly. And this is really nice for breaking apart your application so that it's just you're not dealing with like 5,000 lines of Bicep code in one file, because nobody wants that. So it's you can do this I'm pretty sure you can do this in ARM, but it's a little bit more awkward. And I see a lot of ARM templates that are just kind of monstrously long. So define your outputs. Basically, you can create an output variable, and then you can assign that to, in this case, we're assigning the application insights instrumentation key and connection string, and then we're outputting those as variables. So any questions on Bicep syntax before moving on to the next section? All right, I'll consider that a not yet. We'll walk through some code later. So I want to walk through a few pro tips. Again, these are things I learned building, ARM templates. A lot of these also apply to ARM too, and not just Bicep. But this is a lot of the stuff I've learned, by building Azure infrastructure for different applications, and specifically in this last project where I was building an application infrastructure using Bicep. So pro tip number one, cheat, specifically by going to the Azure Quick Start templates. So the thing about ARM and Bicep as well is that in general, things are a little dicey in terms of getting started. Like it's really hard to start from like a blank page and then build out your Azure templates. So what generally you want to do is you want to find some application that's doing the same sort of thing you're doing. So if you pop out to the Azure Quick Start templates, there's over 300 of these guys, and there's all sorts of different application scenarios that you can reference. And sometimes, you can start and they have like a lot of the basic ones, that you can start with, or alternatively, you can come in here and look at, like, if there's a particular situation you have, you can find a template that maybe has that situation, even if it's not exactly what you need. And it just provides you a good way to kind of start. And more of these are getting converted over to Bicep. So that's something to note too. If you go to the Bicep GitHub, there's also a list of similar quick start templates for Bicep. So regardless, the quick start templates is going to be a great resource for you. Number 2, this button right here is your friend. Pretty much everybody I know who does like DevOps and writes like ARM templates will do this from time to time. So basically, if you're trying to build something and you don't exactly know what the syntax should look like, pop into your friendly neighborhood portal, do the clicky thing, build up your infrastructure in the portal on your like developer account or whatever, and then go to your resource group and export that template. That will export the template as a ARM template, and while that is not going to be beautiful and you're going to have to do some work to clean it up, it will give you a good starting place for your template. So pro tip 1, cheat. Pro tip 2, cheat more using this export template button. So, and again, don't feel bad, because pretty much everybody I know who does Azure stuff does this from time to time. And I've done it from time to time. It's really good for things where it's just, like service tiers and some of the stuff that's just not obvious from the documentation. And once you have that ARM template, you can decompile that bad boy using Azure Bicep. So if you do the AZ Bicep decompile command, you can take an ARM template and it will attempt to decompile that bad boy back into Bicep. I've had mixed success with this one, admittedly. This is one of those things that works 100% of the time, 60% of the time. So while it's not perfect, it's something that's really useful. And the thing is, it's not that hard to, like, once you have an ARM template, like, Bicep to ARM, like from a data point level is like 1-to-1. So if you have like something in an ARM template that's, like name, there's going to be a similar name field in your Bicep template. So it's not like you're going to have to change the names or anything. It just looks a little bit different and has a different format. So it's pretty easy to do this yourself, but it's also a lot easier to just run a single command and decompile your stuff for you. So, sometimes you win. And the final pro tip is build pipelines and just generally use automation to your advantage. I like having things be repeatable and easy to run, and that is a lot easier than if you're using a pipeline, especially if you're building like permanent application architecture. Because in addition, you get like your environments, you get your auditability. It's just a nicer way to be. Like if you're doing something in development just to see if it works, yeah, that's fine if you can just run your deployment script from your machine, but ultimately you're going to want that in a pipeline. So with that, I'm going to shell out and we're going to do a few demos if that's cool with everybody. All righty. So everybody ready for some demos?
Yeah.
All right. Woo. So this is going to be one of those things where we have to use our imaginations a little bit. And in this case, let us pretend that we're building an application. We're going to build an exercise tracker. But before we actually build our deployment for our exercise tracker, we need to build an environment to go to. So we have a basic API. That API has a database. We need an app environment. And this is going to be like one of those cooking shows, because when you run stuff in Azure, it takes a few minutes. So we're going to kind of start with the end result. So this is me just pulling a ready-made cake out of the oven. And this is our resource group that we created. And here's our infrastructure. So we have an app service plan. We have an application insights database, app service, and a log analytics workspace. So you need one of these to go with your app service or with your app insights in modern Azure parlance. And you can come in here, you can see that a little bit of configuration. So our application instrumentation keys are all ready to go. So when we get around to deploying our exercise application, which I wanted to do, but kind of ran out of time on that one in terms of preparations, we'll have a nice little home for our application to go to. So in order to get here, we, of course, run pipelines. So I'm actually just going to go to the code for our pipeline over here, and then I'm going to show you a little bit of some of the results. So we're doing some stuff that's a little bit different here. So in this pipeline, we're going to break this apart into 2 stages. So specifically, we have a build and validate stage. So we're going to run some tests against our Bicep files. And then we are going to deploy those files to our development environment. So in this first phase, we're going to use something called TTK. So TTK is a tool that you can use to run best practices analysis against ARM templates. So you throw an ARM template at it, and if something's wrong with the ARM template, it throws an error. And it checks for things like whether you're using the latest API, whether you're like hard coding passwords, things like that. So it's a good tool to kind of detect issues. So we come in here, we're going to grab the TTK tool, we're going to install Bicep. We're going to build our Bicep templates using the Azure Bicep build command. This is going to turn our Bicep template into an ARM template. So if you run this locally, it's going to look kind of like this. So we'll have a nice ARM template to run our script against. And then we're going to move that into place. Then we're going to run the TTK module against our Bicep templates. And then we're going to copy our files up to the output directory to publish. So we're going to get our parameters file, our Bicep files, our deploy at PS1. We're just going to push those guys all up. And if you want to see what problem looks like, if you come over here to this pipeline, this is what happens if your application fails one of the TTK tests. So you get something like, this application insights instance was using a preview version of an API when there's a non-preview version for that. And what's kind of scary about this test is that the actual non-preview version of the API wasn't documented. So that was a little bit of a head scratcher for a minute, but we get through it. So it's apparently faster than the documentation. So this is what will happen if your best practice tests blow up. This is, of course, what happens if everything's cool. You get your nice pile of green check marks, and then this comes back and everything's a-okay. So we got some warnings here, but oh well. But you can see some of the different things that they're checking for. So kind of a useful thing, a useful linting step for your templates. And again, totally optional. So if you don't want to run this in your pipelines, I'm certainly not going to make you, but it's a nice little addition. After we have our files ready to go, we are going to deploy. And so we have our environment defined. We're going to drop in a resource group in an environmental config file, and then we're just going to run this deploy app script. And that is going to be very familiar to you if you've been, if you've seen this. This is probably the 3rd time you've seen this script, right? So we just easy group create, and we're going to create a deployment group and drop in our environmental config file and our Bicep file directly. So we're not actually, we could drop in the ARM file that we compiled to, but no need to do that. So we just basically are creating an ARM file to validate it and make sure everything's okay. So a little bit of a waste of an ARM file for some validation, but oh well. Validation is good. So if we pop over to our Bicep file. Let's pop over to the correct one. Actually, we'll look at our parameters file. So this, there's no Bicep for parameters, at least not that I know of yet. I'm sure they'll come out with one. Bicep's pretty new. So we just use the standard JSON format for the regular ARM template kind, and that's, it works. And it's not like it's a huge file anyway, so I'm not too worried about it. But if we pop into our application environments, we have a couple of variables up here to kind of determine our naming convention. So generally, when you have Azure resources, you want to name them according to some sort of convention. So instead of passing in names directly and having to have people remember the convention, you can build the naming convention into your template, and then people don't have to work so hard, which is what I'm all about. We have our location, and then we have our different SKUs for our application and our database accordingly. So we have the name and the tier. So this is where we create all the different names for our resources using that string interpolation, and then using our system name, environment, sequence, etc. And so that'll give us some nice names for our different resources. Then we kick it off with a app insights module. So we're going to pull that in and assign that to the app insights variable here. So it's going to be our module reference, and the app insights. Basically, you come in here, we give it our names and the parameters, and then we're going to create a analytics workspace, and then we're going to create a application insights. And this is a modern thing. In the latest API, you have to create this analytics workspace to go with your application insights. One thing that's worth noting here is that with your insights and analytics workspace and all that, they charge you by the gigabyte. So especially in your lower tiers, you want to make sure that you have some sort of quota on there, or else if you make a mistake and you get in an infinite loop of updating, you can have a really expensive time. So this is a way you can kind of have a sort of a cost overrun. So you really need to have the daily quota set and make sure you kind of cap off those resources, and also just keep an eye on things to make sure you're not throwing a ton of stuff into your error log. So it's one of those things that you need to monitor, because it's an easy way to blow up your cost structure. So from there, we're sending out our instrumentation key and connection string back to the, as outputs for the module. If we come back up here, and we're going to use these values down in our application insights, variables in our app settings. So then we're building our database, same kind of deal. So we come in here, we need to build our database server. It requires an admin name and password. You generally don't want to use these for literally anything. So we just kind of give it a random string of characters, or really a hash string of characters. I guess it's not random, for the admin name. And then for the admin password, we're going to give it a hashed GUID, and then just long passwords, so nobody's going to really guess that. And then we can access that database in other ways, like using identity. And then we're going to have our database down here. Another thing that you ran into that's kind of not fun is that in the name field here, you're going to have to denote the server. You don't have a server ID that you point to, which is the kind of thing I would expect. So I guess technically this doesn't matter, but you name your server, and then you have the server name /DB name. So that was, I don't know, that was a bit of a surprise for me. In the application I worked on, we didn't actually have to create a database using Bicep. So that one was a little strange, but whatever. Come back here, then we have our app service. Set up our SKU. We're going to use a Linux app service just because we are doing a .NET Core application. And there's our service plan with our SKU. And then down here, we actually have our actual websites. And this is kind of where a lot of things come together. So we have our server farm that we're pointing to, our app services plan. If you're doing Linux, you need to have this variable for the .NET Core 5, or else bad things happen. and then directly have your app settings. Because when you're building cloud native type of applications, you want to have your your application settings be stored on the machine. And so that's what we're doing here. We're basically dropping in the app insights instrumentation key and connection string. And in terms of next steps on this, the next step would be to set up identity for your database. That would be the next thing I would do anyway. I just kind of ran out of time. So, it happens. But yeah, so that would be the next step for me, and then writing out all the deployment pipelines. And so that's pretty much the application infrastructure here. So does anybody have any questions on that?
No questions, but just a note with that SQL admin password. If you give it a @secure decorator on it, it should make it invisible when it does the deployment versus it being like a string.
Oh, that's a good call out.
Right about the, just, always got to hide those passwords where we can.
Yeah, even if you're getting rid of them. So you're talking about like a @secure attribute, like
yeah, and then just parens, and then when it should make it secure. Then when it puts it in or uses it anywhere versus it just being an open string.
Like it. Oh, it doesn't like that if I do it here. Oh, whatever.
Oh yeah, you only need to do it with the password though.
Yeah, that's true. That's a good call out. Thank you. See, there we go. We'll just edit this real time.
Best way to do it, do it live.
Anything else? All right, well, I guess we can close it up. Let's see here, bring the slides back. All right, so if you want to find out more information, there's a couple of places you can go. I would start with the GitHub page for Azure Bicep. That's probably going to be your best bet. There's a tutorial you can walk through. There's an explanation of the language. It's all good stuff. Following that, you can check out the quick start templates that I mentioned. And the thing that's really helpful too for me is the ARM bicep reference. So if you, let's see here. So this is going to be your API documentation for all things, all the different Azure resources. And what's nice is that Azure is pretty good about using both bicep and ARM syntax in those definitions. So, it's a good way to get a little bit of background knowledge. Honestly, when I was building out my application, I kind of included the reference for each resource as a comment above the resource, and I found myself hitting that up fairly regularly. So an extra pro tip there. But I could see that being a little bit annoying as you gain experience. So it's up to you. Takeaways. Infrastructure as code is really table stakes for any kind of modern architecture or DevOps situation. Like, this is something that we should all be doing. We should not be running on, manually configured hardware pretty much ever if we can avoid it, especially if we're in the cloud. Like, there should be no manually configured anything in the cloud. So infrastructure as code is table stakes. There's a lot of different ways to do it. Procedural ways, declarative ways. It doesn't really matter as long as you're doing some kind of infrastructure as code. Like, my thing is there's usually a lot of right answers, just as long as you aren't doing the wrong things, which in this case would be not using infrastructure as code. So I'm not going to fight you on any particular infrastructure as code technology. Use pipelines to build up your infrastructure. It just makes things repeatable, auditable. It's a nice way to do things. And finally, Bicep. It's like ARM, but better in pretty much every way. So if you're going to build Azure resources, which you should, Azure's great. If you're going to build those resources using ARM, which you should because it's declarative, and declarative is a little easier to use than the procedural ways, you should not use ARM and you should just use Bicep instead. Not that ARM is bad, it's just not as good as Bicep. Bicep is easier to use and should be your default choice for any kind of Azure infrastructure. So with that, go get yourself the, hit up that GitHub page, learn Bicep, check out the tutorial, and crank out some templates and build some infrastructure. If you want to check out the demos, here's the GitHub link again for your consumption. I'll throw it in the chat too, just to make it extra easy. And that's all I got. If anybody has any additional questions, I can hang around. Otherwise,